Okay, what I'll do is talk about the state diagram process and how it applies to this winter project for the spring of 2021. So the state diagram process consists of rectangles, which represent states, and trigger events or conditions that cause the diagram to advance. So in this case, I always start out with names that mean something, like power up, okay to run, pump 1 ready, pump 2 ready, etc. But in the end, the states take on numerical values because in the controller, it works better with numbers. And also the state values can be set up to remain even if power fails and comes back on. So it is possible to make the system restart where it left off, or if you'd like to pause it, you can pause it and resume operations where it left off. So the main advantage for doing it this way is that as the operations become more complex, it's difficult to use just simple ladder logic because you wind up having seal ends and ways to break the seal ends, and sometimes it gets very complex. And already this project kind of borders on some of that complexity. So this is a much simpler way to do it. Let me walk you through the steps here. So I'm going to try and use some of these tools, like the highlighter tool. Here's the power up state. So when power is applied, we need to start up in state 0. I'm looking for a highlighter. I don't see one. Okay, I'll just make the best of what I've got here. So all outputs are off in state 0. So if start is not pressed, then I can go to state 10. So in the project description, I mentioned that the start button allows the system to operate. If I start it up with start already pressed, I don't really want to do anything because that means maybe somebody sat a book down on the start button, or maybe they're leaning up against it, and who knows really what's going on. So if start is not pressed, then I can go ahead and start. So then I'm looking for the start button and the run switch, or the run switch off and the start button. So one way or the other, when I press start, I'm going down one of these pathways. Okay, so let's go down the right side first, because that's pump 1. That's the way I drew it here. It could have just as well have been the left side. But if run is off and I press start, pump 1 is ready to operate. So that's state number 40. Now, the state numbers are kind of arbitrary. I just picked numbers. Could be 100, 200, 300, 400. It's a good idea to leave some space between the state numbers so you can add things that you forgot in between. Okay, it's not mandatory. You can go 1, 2, 3, 4, 5, but you don't have any room between state 2 and 3. It goes in whole numbers. So state 40, it says pump 1 lamp is on. So that's sort of the pre-pump condition. 3 seconds later, I go to state 50, turn on the lamp, which is already on, and I turn on the pump. Okay. 30 seconds later, I go to a state called 70, which is wait, and then I go immediately back to power up. So power up takes me way back up here. Okay. So at that point, I'm going to wait for start to be not pressed again. So if I hold down the start button somewhere down here, like 50 or 70, when I get back to the top, I'm going to have to let go before it will restart. So that takes care of the problem we were talking about. How do I make sure it restarts properly? Just by switching our focus to a state-based approach, we can avoid that. So let me change colors here. So on the left side, if the run switch is on, I go to state 20. That's my pump 2 ready. 3 seconds later, I go to state 30. Pump lamp, pump is on. 30 seconds later, go to wait. Then I go back to power up. Okay. So the neat thing about this is that when I'm in state 20, for example, or 30, or 70, if the run switch turns off, I'm not looking at it anymore. So I just basically ignore that until I get back around to the top, and then I make a decision what to do again. So in one simple change of our approach, we can solve all these timing issues and one-shot issues and, edge triggering and all these tricky forms of logic that sometimes they'll come back and backfire because, sometimes it's a matter of a millisecond here or there and it doesn't work. And so this approach is much more stable, and it's always good to map your process out anyway, so you have a good understanding of how it progresses, right? So if I had, let's say the project said something like there was a reset button. If I press the reset button from any state, maybe I want to go to power up. So I could easily pencil that in as a backwards arrow that would take me back to power up. So making changes to your process is very simple with state diagrams if you start out with that in mind. So really all we're doing in this approach is we're changing the number that we load into the variable called state. And the state number determines what outputs are on and how the whole system operates. So I'll show you here in the ladder logic that the state diagram programs have a very consistent look to them. So it's not nearly as creative as just ladder logic, but it's also not very unexpected in the way it operates. And we really want things to work reliably. We don't like surprises. That just leads to problems and things that we have to fix later. So let me wrap this video up, and I will add an additional video that shows how to use the software to create a structure that will follow this diagram. Okay, on this video, what I'll do is I'll develop what I call a template for using the state diagram approach. And you don't have to use this technique, but it does simplify your programming. And that's always a good thing. It makes it more consistent and easier to modify if you decide you need to modify it. So I'm going to set this up for the standard setup that we have, which is one card. And I'm going to give it a name that I can come back to. Okay, I did a little bit of this, so let me delete what I did so that we can start kind of fresh. So here's where it starts. In the diagram, let me see if I can open the diagram. I think it's here. Let me shrink some windows here. Okay. So here's our diagram, and I did not save the changes that I made to it, unfortunately. But pick a color that's easy to see. Okay, so here's state 0. It needs to start up in state 0. So if I look at my ladder logic, what I have is an instruction called move. Okay, let me open that up. So move data, what it does is you can use it to move numbers, to copy numbers. Okay. Now there's several ways you can do this. This is just a simple way of doing it. So what I'm going to do is move a number 0 into a tag called state. Okay. So when I do that, I'm in state 0. The way I do that is I have a coil at the bottom of the program called first pass. Now there is a special coil. Let's see if I can find it for you here. There is a special coil called first scan. Okay. So we don't have to do the first pass. I can delete that. Let's just get rid of it. So SD is system data. First scan means the first time it's gone through the program. So if I haven't gone through the program yet, I'm going to move a 0 into the state. So let's see if we can test this. I'll just go online with the simulator. We can't see anything happen because it's so quick. You can see a 0 there. We can see that it's on right now. Okay, so I guess we have to assume that it worked correctly. There's no way to see it work. It's so fast. Let me think for 1 second. Let me add a new rung below it. Let me put a. Well, I can't do what I'm thinking of doing here. Let me back up just a tiny little bit. Let me put a first pass, a first scan contact. I'm going to have a coil called test. Okay, let's go back online. Try not to get too far off the topic, but I'd like to try to illustrate how this works. So the first scan bit, it is false after the first scan. So, unfortunately we can't see it. Let me think a little bit more here. How can I show that it actually did work? I think if I seal in the first scan contact. Let me try this. Just 1 second. Let's try that. And then this is going to be test. Okay, so let's go online. If this works, when I hit the first scan, I'll turn on test and I'll seal it in. So it is sealed in. So what that tells me is that this does trigger for one scan. It is true that activated the test coil and that sealed in the test coil. So it does work. It's true for one scan and then it's no longer true. Okay, so that's a long discussion of a simple thing, but it's good to go through that. So let's get rid of that. Okay. So we know that when it powers up, it's going to put a 0 into the state. Let's look back at our diagram again. So if start is not pressed, go to 10. So here's how we go about this. And there's a definite pattern to this. So let me just draw for a minute. Okay, the first thing is the state equal to 0? If that's true, and start is not pressed, what I want to do is I want to move a 10 into state. Okay. So what I'm really doing here is I'm changing the state value based on these conditions. So notice what I've got set up here. On the left side, that is if I'm in this state here, which is 0, and I am not pressing start, I want to go to 10. So the stuff on the left side basically is the current state and the trigger. Okay, that is on the left side of your rung. What's on the right side is the next state number, which is going to be 10. Okay, so let's follow along with that. So now what I'll do is I will copy that and paste it. Okay, so now if I'm in state 10, let's look at the instructions again. I think I closed them. Let me see if I can open them up. Well, it didn't save it once again. That's okay. So if I'm in state 10 and start is pressed and run is on, so let's do that one first here. Let me get my marker out. So now I am here. Okay. So 10 is on. I'm in state 10. Start needs to be open. Run needs to be open. So let's do that. I'm going to right click, replace with an open contact. I'm going to pull down an open contact called run. Okay. So if that's true, I go to state 20. So now I'm going to go to 20 here. Okay. So we're not worried about what's going to turn on and turn off. Not yet. That'll come next. Okay. We're trying to check off these boxes here. Okay. So in 20, if 3 seconds go by, I go to 30. Well, I'm going to paste again. So in state 20, if 3 seconds go by, I want to go to 30. How do I do that? Well, instead of a contact here, what I'm going to do is put a timer. So let's go to monitor mode. Oh, sorry. Let's go offline. Okay, I just need some space here. I don't have to go offline, but I need a little space. So what I'm going to do is put a timer down here. Right here. This can be timer 1, time relay 1. Can be a preset of 3,000 seconds. And that, I'll just sketch that in over here. Let me patch this over. So if that timer turns on, I want to go to 30. So I'm going to get an open contact out of TR1, and there I have it. So if I'm in 20 and the timer turns on, I go to 30. Okay. Let's just see why. Okay, it's fine. And I'm immediately going to go back to edit mode. Okay, so 20 timer 30. 20 timer 30. So now I'm down to here. So 30 timer 70. Okay. I'm going to copy this one because it's got what I want. I don't have to make so much stuff. So 30 timer 70. It's going to be timer 2. 30 seconds, 30,000 milliseconds. This is TR2. Okay. So this one, 30 timer 70. So 30 timer 70. So I am finished with this side right here. Finished with that side. Let's go to this side. 10, run is off and start. Go to 40. Okay, so I'm going to go back and look and see where that was. Here, 10, start, run. So I think what I'll do is I'm going to copy this. I'm going to try to insert the copied rungs. So it sort of keeps it all together. So 10, start, not run. So let's replace that with a closed. Let's look at it again here. 40. Okay, so this one is 40. Okay. 43 seconds, 50. Let's find the equivalent over here, which was this one. So let's copy that. Let's insert the copied rung. 20. let me go look back here. 43 seconds, 50. So here it's, I'm not sure it really helped to put it where I did. Let's cut that. And I'm going to paste it down here. Go back. Okay, so 43 seconds, 50. So here's 43 seconds. This will be timer 3. Timer 3. 50. Okay. So we'll try the last one, then we'll go back and double check everything. So 50, 30, 70. So that's just like this one. So I'm going to copy that, paste that here. 50, state 50. 30, another 30 seconds. So that's going to be TR4, I think. TR2, TR3, TR4. TR4, 70. So it's okay to go to a state from 2 different ways. There's nothing wrong with that because I won't be doing both of them at the same time. So if you can see both of these, this is 30 leads to 70. This is 50 leads to 70. And 30 leads to 70. And so does 50. So there's nothing wrong with that. That's the plan. Okay. So in 70, don't do really anything. I just go back to power up. So that's easy. I'll just copy this one, I guess. I just need one that I can copy and paste down at the bottom. So if state is 70, go to state 0. And I don't need anything here. That's easy. It almost seems like it's too easy. Let's double check that. So when I get to 70, I just go to power up, which is 0, and yeah, that's fine. Okay. So we can check that syntax to make sure it looks okay. No problem. So we're not finished just yet. So next we have to address the output conditions. So all I'm going to do is look for outputs that are on. So 20, I've got, well, let's do this side. 40, I have pump 1 lamp. Okay. So I'm going to copy this one once again, paste it. So if I'm in 40, I want to turn on pump 1 lamp. Let me double check that. 40, pump 1 lamp. 50, pump 1 lamp, pump. Okay, so what I'm going to do here, since I have 2 conditions that operate the same thing, I'm going to copy this and I'm going to paste it. And I think I'll put it there. This is a 50. So 40 or 50 will turn on. Can't go there. Let me work with this for just a second. Okay. And I'm going to work with this side here. Okay. So 40 or 50 in pump 1 lamp is on. Okay. 50, I have pump 1 on. So I'll make a new line for just for that. Okay. And I'll get rid of this. Do a little cleanup here. So 50, pump 1. Just pump 1. Okay, so let's go close to the top there. Let me add another row, space it out a little bit. So there's pump 1, lamp, pump 1. I'm going to copy both of these and insert below. So pump 2 lamp is on for 2030. Okay, so here's 20. See how easy this is? It's not so much thinking about it, it's more just the structure. The thinking part is here in the diagram. Then the ladder logic becomes just getting the numbers right. It's so much easier. Pump 2 lamp, pump 2. Pump 2 is on when? State 30. Okay, so that'll be a 30 right here. Okay, so let's look at it again. That's it. I'm literally done because I've checked off all the boxes. I've got all the triggers. I've got all the output conditions. Everything's done. Probably what I'd like to do is just so I can see things operate. I'm going to create a new run. I'm going to do pump 1 lamp, pump 1, pump 2 lamp, and pump 2. And then my output will be a coil called test. Test won't do anything, but it just sits there. I need a coil over here or it will not work. So let's go to monitor mode. And you'll notice that, let's go to the top here. What state are we in right now? We are in state 10. Okay, why is that? Well, start is not pressed, so I go to 10. So in 10, I'm waiting for the start button because run is not activated. Okay, so if I turn on the start button, I'm going to go to state 20. And then 3 seconds later, 30, and then 30 seconds later, 70. So let's give it a try. Let's activate the start push button. I'm going to hold that down. And let's watch what's happening here. I lost track of where I am. Let me look back up here. Oh, classic mistake. This has to be an open contact because it's only true the first time through. So let me go to edit mode. And let's replace that with an open contact. Okay, let's go to monitor one more time. Okay, so it zeroed me out. Okay, and it's in state 0 because I'm holding the start button down. So let's release that. Now I go to 10. If I hold down the start button, I'm gonna do it right there. I'm in state 50. Okay, there we are down here. So let's watch it run for a second. Let's look at the outputs as well. Okay, so I've got the pump lamp on, I've got the pump on, now I've got nothing on. So let me do that one more time. There's something that I saw go by that you probably didn't notice, but let's try it one more time. What I'm looking for is that 3-second timer on state 40, which is right here. I want to see that run, so I'm going to turn on start and I'm going to zip down there to it. There it is. Okay, it's quick. See how it goes back to 0. And it does that because once I leave state 40, this logic doesn't work anymore. Instead, it hands it off to state 50 and it runs this logic. And then state 50 runs the outputs. So here in just a few seconds, you'll see these outputs turn off. Okay, so let's let it run. It's too soon to make changes. So there it goes. So let's go back to the top here. Up here at the top, let's turn off the start push button. See, I went back to state 10 because that's a valid starting condition. Let's turn on the run switch and let's hit start. Okay. So now we're down on the left side, and let's look at the outputs down here. Get down there quicker. Okay, I'm on pump 2 now. Okay, let's just let it run, and you'll see that they'll turn off after 30 seconds. No, they should turn off. They will. It's just a long 30. There it goes. And now, since I left the start button on, I'm in state 0. That's almost like a holding pattern. So I let go of the start push button, go to state 10. If I turn off the run switch, nothing happens yet because I have to trigger it, right? So if I turn it back on, trigger it, I'm going to turn that off real quick. I'm going to turn this off real quick as well. But since I started down the pump 2 path, pump 2 is still on. And it's going to stay on for 30 seconds. Mm, 16, 17. I'm going to zip back down. Turn off here in a few seconds. And we are reset once again. Okay, so it works great. It's different. It looks different, but you're doing all your thinking over here on the state diagram, rather than trying to pull contacts down and seal in around contacts, all those things that we normally do in motor controls. We're doing it with numbers instead, because we can. One thing that, let me show you, let me just look for the right thing here, tag database. Okay, the tag database, I'm looking for my state tag. Here it is right here, state. I have to go, let's go offline for a second. I'm looking for, I want to make it retentive so it doesn't forget. Trying to think, where is that in this system here? Give me a second to look around here. I'll find it here in just a minute. I'm looking for the way to set up the, must be here under setup. Let's see, project options. Clear registers on power up. Okay, well, I think this is where I want to be, because none of them are set to clear on power up, which means they retain their values. Clear registers on program upload. Program upload. Well, the one that I'm more concerned about is on power up. Okay, and I think we're in a good spot right here. So we are not going to erase any of the data when we power up. And let's double check one thing here. The state value is an R register. It's a register. It's a 16-bit register. So everything's fine. Okay, I'm just checking on things to be sure. So this is a great solution to this problem. And if you look at the structure, hopefully it will make sense at this point. We have the current condition, we have the trigger or the exit condition, and then where are we going to? So it's equal, contacts, timers, whatever we need to get where we're going, and then our destination right here. You can go to a state from many other states. You just have to trigger it to get there. You can go forwards and backwards, whatever you would like to do. This has no backwards paths on it, but if we wanted to go backwards, we had another push button. We could just go back to power up or whatever we want to do. It's not a problem at all. It takes the complexity of the ladder logic and puts it on paper instead, which is where I've always said it should be, because we think better on paper. We have more, it's a freestyle, you're sketching, you're just drawing boxes and lines. So you're not having to focus on contacts and open and closed and any of the details, right? The details will come in the software, but the thinking part on paper is where you want to put your effort, okay? Luckily, most of these transitions are pretty simple. Sometimes there is no transition, like from 70 back to 0. It just goes. If you want a delay, you can add a delay, but we don't want any delays. So anyway, to kind of summarize, this is a very simple way to tackle complex problems that have all sorts of cycles and restart points and restart conditions and fault conditions. Anything you can think of, we can put it in here. If you wanted this thing to fault, if you had start pressed when it powered up, we would jump out to state 100, and that would be a fault condition, and I could flash both of the pump indicator lamps at a high rate of speed. Whatever I want to do, I can easily add that to it. So hopefully this makes sense, and hopefully you'll like this approach. It really works well for complex projects, including the one that I call winter weather project. So I'll go ahead and wrap this up, and you can look at this and think about it.